Hello brother, today's our topic is transfer function. So what is the transfer function exactly, and what is the formula for that, and how it is going to calculate? See, transfer function is nothing but what we are indicating by T and F. T is stand for transfer, F is stand for function, transfer function, right? So generally it is nothing but Laplace of output divided by Laplace of input. This is called as a transfer function. So what is exactly Laplace? Laplace is a very much bigger topic, but for transfer function we want only 3 formulas from Laplace. So what are that formula? What is the transfer function? Which type of numerical may ask in your final exam? Everything we will see in this video, in this session. Okay, so let's start with the transfer function. Okay, so see again, transfer function indicating by T dot F, or it is indicated by G of S. Okay, what is that S variable, and what is the G of S? G of S is nothing but transfer function. Formula for that is C of S upon R of S. Okay, what is that exactly? See, we assume that any block for any system, any control system, we assume that this is the control system. Okay, this is the control system, right? So that control system is indicated by, suppose this is a control system, right? What is the output of control system? What is the indication of output? As we know, we are always indicating by C of S, right? And what is the indication of input? It is always indicated by R of S, right? See, why we use S here? Because we have habit to use T, right? T is a time function, right? But what is the S? So here Laplace play their role. See, when we are taking Laplace transform of variable T, Laplace transform convert that variable into their own variable called as S. Okay, so Laplace transform is a function which convert T variable into S variable. S is a variable of Laplace, or we call it it is a frequency. Okay, so see, here we are taking Laplace of input as well as Laplace of output. That means all calculations are done in the S variable only, right? When we are taking transfer function, means we are taking gain here. What is the transfer function? That means it is a gain. So gain is indicated by G of S is equal to output upon input. So output is in the form of Laplace only, because it is a variable of S. So it is the Laplace of output. What is the Laplace of output? C of S divided by what is the input of Laplace of input? R of S. So same formula we are used here. See, what is the function, transfer function, or what is the gain? Laplace of output upon Laplace of input. So here Laplace of output is C of S and Laplace of input is R of S, and this is the any system, any control system, right? So for any control system, what is the transfer function or what is the gain? It should be a C of S upon R of S. C of S is a stand for Laplace output and R of S stand for Laplace input. Okay, let's take simple example based on the transfer function. Let's take new page. Okay, suppose example is, okay, before we start with the example, we want to some formulas which are used to solve the numericals. What are that formulas? See, this is the resistor, this is the inductor, right, and this is the capacitor. All 3 components are called as a passive component, right? R resistor, L inductor, C capacitor. Okay, all 3 variables, all 3 components are called as a passive component. Okay, so what is the voltage across resistor, what is the voltage across inductor, and what is the voltage across capacitor? See, always voltage across resistor is I into R. Voltage across resistor is I into R. Voltage across inductor is L di by dt. L di by dt, and voltage across capacitor is 1 upon C integration of I dt. Okay, so these are the voltage drop or voltage across R, voltage across L, and voltage across C. Okay, these three formula we want to solve the example. This is the voltage across resistor, voltage across inductor, and voltage across capacitor. Okay, again we want Laplace of each one. See, Laplace transform of 1 is 1 upon S. But we don't want this formula, we want only three formula from Laplace transform. That is, see, Laplace is a function which convert t variable into S form. For example, suppose here we are assuming that I, it may be in the I of t like this. So Laplace convert into the I of S. Okay, this is the first one, first formula we required. Okay, second one, Laplace of derivative. Derivative means d by dt, right? Laplace of derivative is S only. And third formula we required, this one is second. Third formula we required to solve the example, that is Laplace of integration is 1 upon S. So these three formulas we require. First three formula, that is the voltage drop, right? And last three formulas are Laplace transform. Okay, these six formula we required to solve the examples. Okay, let's start first numerical. Okay, they said find transfer function. They said in the numerical find transfer function of circuit. They are giving here resistor, then capacitor, then okay, this is V of t, right? This is VO of t. Okay, this is the R and this is C. Let's start. See, this is the R and this is the C, right? Now what to do? See, again, as we observe the complete circuit diagram, in the circuit diagram there are two components, that is R and C. So what are the steps we should follow to solve this example? First step is apply KVL. KVL stands for Kirchhoff's voltage law. Kirchhoff's voltage law. So in the KVL, we are applying KVL at input side. So what is the input side? So this is the positive point and this is the negative point. That means it is starting with the positive to negative, right? Okay, and that current we are assuming that I, or we call it the I of t, right? And this is the first step, right? When we apply the KVL, Kirchhoff's voltage law, that means we are taking voltage across each component. Okay, so initially what we get, resistor we get from positive point. Initially which component we get? We get resistor first, right? So voltage drop across resistor is the VR, right? Then there is a capacitor, right? plus VC is equal to 0, right? What is the VR? As we see in the formulas, what is the VR? VR is nothing but I into R. So we are putting R as it is, and I we are assuming that I of t plus what is the VC is 1 upon C integration of I of t dt is equal to 0. So this is your first step. This is your first step. Again, taking Laplace transform, R as it is, I of S, right? Because Laplace transform convert t into S plus 1 upon C. See, again integration, we want Laplace of integration. So what is the Laplace of integration? It is 1 upon S I of t, I of S dt equal to 0. So this is, see, what is the, again that integration we convert, so dt is not required here. Now see what is the common in both terms. This is the first term, this is the second term. What is the common? I of S is common, so R plus 1 upon SC, and outside the bracket what is the common? I of S is a common, right? This is the first step, right? Now let's move on the second step. What we do in the second step? We are taking apply KVL at output loop. So as we see in the output loop, what is the output loop? So this is starting with a positive, this is negative, so positive to negative, this is the direction of current, okay, and current is again I of t only, right? So it is positive, only one component is there, that is C. Sorry, this is not equal to 0, this is equal to Vi of S. This is the Vi of S. This is the Vi of S. Why it is the Vi of S? See, at the input side, this is the Vi of t, right? This is the Vi of t. So it becomes Vi of S after Laplace. So after Laplace, that means this is a t. Okay. This is again t. Here we are taking Laplace, that means it is become S. And output side is VO of t, right? So VO of t, it becomes VO of S. So let's take output loop. Only one component is there, that is C. So VC is equal to VO of t, right? So what is the VC? VC is nothing but 1 upon C integration of I of t dt is equal to V of t, right? Taking Laplace both sides. Taking Laplace both sides, what's happen? 1 upon SC I of S, right? Because as we know, Laplace of integration is 1 upon S is equal to VO of S. Okay. See, now we have two equations. This is the first one, this is the second one. Okay, let's take division. What we are going to divide? Equation number 2 divide with equation number 1. 2 are equal as a B, right? And this become A. Okay, so equation number 2, for the second equation, 1 upon SC I of S is equal to V of S, right? Divided with what? Equation number 1. Equation number A, what is that? R plus 1 upon SC, right? R plus 1 upon SC I of S, and this is the VI of S. Okay. Now see, I of S and I of S both are cancelled here. See, I of S both are cancelled here. So what is the remaining? See, this is the transfer function as we see in the initially. Output upon input means transfer function, or we call it as a gain. So we get directly transfer function here. See, now 1 upon SC we put as it is, right, divided by, see, now we are taking here cross multiplication. SC is cross multiplied with the R, so it becomes RCS plus 1 divided by SC. Okay, this is the cross multiplication. Now see, in the numerator and denominator, common term is there, SC and SC. So both are cancelled here. So what is the remaining? The remaining is 1 upon 1 plus RCS. This is your transfer function of given circuit. Okay. Let's take more numerical based on the same topic. So next numerical is, they are giving 3 components here. First is resistor, second is inductor, third is capacitor, right? This side is the output side and this side is the input side. Okay, this is the VO of S and this is VI of S, or we call it the T. This is T. Okay, they are giving this circuit diagram and they told us to find transfer function of given circuit. Okay, again for transfer function what to do? We are considering one current. That current is I of t, right? And again this current is I of t. Okay, this is your output, right? This is your input. Okay, again same, we are following same steps. 2 steps are there. First step is apply KVL. For the first step is apply KVL at input side. When we apply KVL at input side, what's happen? We get voltage across resistor plus voltage across inductor plus voltage across capacitor is equal to VI of t, right? What is the voltage across resistor? It is a R I of t, right? Plus what is the voltage across inductor? It is a L di by dt. This I is I of t, right? Plus what is the VC? Is the 1 upon C integration of I of t dt is equal to VI of t. Okay. Now when we take Laplace transform at both the side, Laplace, what's happen? See, R we are taking outside, so what is the I of t? I of t is become I of S, right? Plus L, this is S, I of S, because in Laplace of derivative is S, right? Plus Laplace of integration is 1 upon S. So 1 upon S, and see that it is I of S is equal to Pi of S, because all t are converted into the S form, because it is 1 second. Okay. See, now what is the common in all term? See, R we put inside only, LS we put inside only, 1 upon SC we put inside, and we are taking I of S, sorry, this is again I of S. And this I of S we can put outside, so I of S is equal to V of S. So this is your equation number 1 or equation number A. Now what is the second step? Apply KVL at output side. When we apply KVL at output side, what is the circuit? See how many components are there? Output side, this to this side. Okay, that means positive to negative, only one component is there, that is capacitor, right? So we get only one equation here, VC is equal to V of T. What is the voltage drop across capacitor? It is 1 upon C integration of I of T dt is equal to V of T. Okay. Then again take Laplace transform both sides. When we take Laplace transform, so it is 1 upon C, and again Laplace of integration is S, right? So I of S is equal to V of S. Okay. Again, what is the third step? Third step is again common here. What is the third step? We are taking equation number 2 divide by equation number 1. So what is the equation number 1? This is equation number B, right? So we call it as a, this is B, so this is A. One second, we are dividing B, and this is, one second, this is B and this is A. Okay. Now B is at the numerator, so it is 1 upon SC. I of S is equal to V of S, right? Divided by, what is the equation number A? It is R LS 1 upon SC. Okay. So it is R plus LS plus 1 upon SC outside the bracket I of S divided by VI of S. See, VO upon VI, it is transfer function, right? Now see, I of S available at both the side, both the numerator and denominator, so both are cancelled here. Now 1 upon SC as it is, right? Cross multiply here, SC is cross multiply with the R, so it is R CS plus cross multiply with the LS, so it is L C S square plus 1 whole divided by SC, right? Now again both SC SC get cancelled. What is the remaining? 1 upon C square term we put initially, so it is S square LC plus S RC plus 1. I'm just reform the all step, the square term I put initially, then this term, then plus 1. Okay. So this is the transfer function of your given circuit. Okay. Likewise, they are giving any type of circuit, just try to solve it. Okay. Again, let's take more numerical. One more numerical. Numerical is find transfer function of this network. Okay, this is the given. There are two resistance, that's why R1 and R2, two capacitors C1 and C2, right? They told us find transfer function. Okay, now see what to do. This is the input side, this right side is the input side, and this is the output side, right? Again for that we want equation, right? See, so there are two loops, total 3 loops are there. So this is the first loop, current direction is like this. We consider here I1 of T, right? For this loop, current direction is like this. We consider here I2 of T, and current direction is like this. This one I3 of T. Okay, so we are considering here 3 currents: I1 from first loop, I2 from second loop, and I3. But as we know, generally we are considering same current at the output, so it is I2 again, because there is no extra additional component. Okay, so there are two currents, I1 from input side, then I2, and then I2, right? Now we are applying KVL at the first loop. Apply KVL at loop 1. So when we apply KVL at loop 1, there are two components, R1 and C1. Let's start. Voltage drop across R1 plus voltage drop across C1 equal to Vi of t, right? What is the voltage drop across R1? It should be R I1 of t. So what is the voltage drop across capacitor? It is 1 upon C integration of I of t, I1 of t dt, right, is equal to Vi of t. Again, we are taking one mistake here. We are making one mistake here. See, from C1 there are two currents flow. One is the I1 from this side, right, and second one is the I2 from this side. So this branch of C1 carry two type of current, and both current directions are opposite. See, I1 is going down from C1 and I2 is going up from C1, right? So here two currents are flowing from the capacitor. That's why it is like this, minus I2 of t also, right? Because both having opposite direction, that's why we are taking minus. Okay. Now let's take Laplace transform. When we take Laplace transform, one second. Laplace transform, that means all t are converted to the s plus integration. Laplace of integration is 1 upon s, and already c is there, and this is the I1 of s minus I2 of s is equal to Vi of s, right? Now this I1 of s, I1 of s, I2 of s, right? See, this is the bracket, right? This is the bracket, right? Okay. Then suppose we simplify this step. R1 is as it is, right? Then I1 of s is as it is, right? Plus 1 upon sc multiplied with the I1 of s minus 1 upon sc multiplied with the I2 of s, right, equal to Vi of s, right? This is the first equation we called as A. Let's take the KVL at the second loop. KVL at loop 2. Okay. What is the loop 2? How many components are there? See, it is starting with the capacitor, then resistor, then capacitor, right? That means there are three components. That means initially there is a C1, voltage across C1, plus voltage across R2 plus voltage across C2 is equal to 0, because there is no supply, right? Voltage across C1, what is the voltage across C1? It is 1 upon C1, see, this is C1, 1 upon C1 integration of I1 of, let's take I2 first, because this is the second loop, I2 of t minus I1 of t dt. Now you may understand I2 minus I1, why we take minus or why we take subtraction, because there are two currents from this branch. Okay, plus what is the VR2, voltage drop across R2, it is a R2 I2 of t, right? Plus what is this C2, so it is 1 upon C integration of I2 of t is equal to 0, right? Now 1 upon C1, let's take the Laplace transform here. Laplace transform, so 1 upon C1, and again integration Laplace is 1 upon s. This is I2 of s minus I1 of s, one second, I1 of s plus R2 I2 of S plus 1 upon C S, because Laplace of integration is 1 upon S, and see it as it is I2 of S equal to 0. Okay, let's move on the next page. Okay, see, now here we get the second equation of second loop. Can we minimize this? See, 1 upon SC I2 of S minus 1 upon SC I1 of S plus R2 I2 of S plus 1 upon SC I2 of S equal to 0. See, can we put out I2 of S common here from this three term? So 1 upon SC plus R2 plus 1 upon SC, and outside is I2 of S, right? Minus 1 upon SC I1 of S. Okay. Now, when we apply KVL at third loop, see, in third loop, what are the components are available? Only C2, right? So let's apply. This is equation number B, called as equation number B, right? And when we apply, because there are three loop, that's why we apply KVL at loop 3. Okay, so only C2 is available there, V of T, right? What is the voltage across capacitor? It is 1 upon C integration of I of T dt is equal to VO of T. Now taking Laplace both side, that means 1 upon SC I2, sorry, this is I2, right? I2 of S is equal to P of S. Okay. Now see, we get I2 here, right? Now for transfer function, what to do? For transfer function, this is equation number C. Now we have three equations, but for transfer function, what is the formula for transfer function? VO upon VI, right? So VO, this is VO, that is equation number C should be in the numerator. And what is about VI? Because VI having three equation here, three equations. So in the first equation there is a VI, right? This is the VI, right? So we are taking division of first and third only, right? Okay, so the equation C divide equation A. Okay, so what is the equation C? It is 1 upon SC I2 of S is equal to V of S, right? What is the equation number A? See, equation number A is this one. R1 I1 plus 1 upon SC1 I1 and 1 upon SC2 I2 is equal to VF. Okay, I think this is SC1 only. This is SC1 only, by mistake I put here 2, but it is SC1. Okay. Okay, so it is divide R1 I1 of S plus 1 upon SC1 I1 of S minus 1 upon SC1 I2 of S divided by, let's take this here, VO of S upon VI of S. Okay, so this is your transfer function and this is your convention. You try to minimize it, but as you know, it is very difficult to minimize because there are two variables, I2 and I1, both are available, so it is not cancelled at any case, so that's why we put as it is. Okay, so like this example you may get in your final exam, so try to solve this example using the basic concept of applying KVL. Here there are three loops, that's why we are using three KVL equation to get our answer, right? So if you have any doubt regarding this transfer function, or if you have any numerical based on this transfer function, please WhatsApp that numerical to me. That means I will provide you solution of that numerical. Okay, thank you.